We're looking at Chapter 4, Rational Expressions and Equations. Unit 2, Chapter 4, Section 4.3. We're going to perform operations on rational expressions. In this lesson, we'll learn how to multiply and divide rational expressions. Once again, we'll still identify the NPVs. Recall that we'll have to know how to factor binomials, and that there are two types of binomials that we'll need to know how to factor. That is the greatest common factor and the difference of two perfect squares. When we factor, we always look for the greatest common factor first. Let's go back and look at what non-permissible values are. They are values for a variable in a rational expression that make the denominator of a rational expression equal to 0. So in this case, where we have 4 over x cannot equal 0, since that would make this expression undefined. In 1 over x plus 2, x cannot equal negative 2, since that would make the denominator of this expression 0, and once again, undefined. We must always factor before we simplify. If the polynomial in the numerator or denominator is not factored, we must factor before simplifying. So we have x plus 4. We're unable to factor it. X squared subtract 16 is one of our special binomials. There's no common factor, but it is a difference of two squares. And so we factor it to be x plus 4 times x subtract 4. We can now cancel common factors of x plus 4 and x plus 4, leaving us with 1 over x plus 4. Sorry, x subtract 4. X cannot equal negative 4, and x cannot equal 4. So for multiplying rational expressions, we must factor, if possible, the numerator and denominator of any rational expression. So factor before we move on to the next step. As you can see, we are unable to factor x plus 6 or x plus 5 or x plus 1, yet there is a common factor in 2x plus 12. The common factor being 2, and we take it outside. Now, that leaves us, when we multiply the two polynomials together, or the two rational expressions together, we get x plus 6 times x plus 1 all over x plus 5, 2x plus 5, x plus 6. There is a common factor of x plus 6, and so we cancel. We are left with x plus 1 over 2 outside of x plus 5. Anything that has been in the denominator is a part of our NPVs. So we have x cannot equal negative 5 right here. And right here we have x cannot equal negative 6. So therefore, x cannot equal negative 5 and negative 6. Let's find the product once again. Once again, we must factor before we try to cancel any of the common factors. As you can see, the numerator in the first rational expression, we have a common factor between x squared plus 2x. So we take the x outside, we have x plus 2 remaining. In the denominator, we have a difference of two perfect squares. So we factor x squared subtract 4 to be x plus 2 times x subtract 2. 2 subtract x is not factorable. And then we have 5x plus 5. There's a common factor of 5 and we take it outside. Now we are ready to cancel any common factors. So we have x plus 2 and x plus 2. We also have opposite factors. As you can see right here, we have a positive x, and up here is a negative x. Here is a negative 2 and a positive 2. These are opposite factors, and we can cancel and get negative 1. So when we simplify, we have negative x over 5 inside of x plus 1. Don't forget the NPVs. The NPVs, of course, are going to involve anything that has ever been in the denominator in this whole process. So we have right here, we have x cannot equal negative 2, and x cannot equal 2. In this rational expression right here, we have x cannot equal negative 1. So we have 3 NPVs. X cannot equal negative 2, or 2, or negative 1. Let's have a look at another example. If you wish, you could pause the clip and factor the polynomials. Solve the solution. I'm going to continue. When I factor the top, the numerator of the first expression, I have x plus 5. X subtract 5. It's a difference of 2 perfect squares. Over. This is going to be 3 outside of x squared subtract 9. Times. There's a common factor between 6x and 18. 6 side of x subtract 3 over x plus 5. Yet this is still factorable. So we have x plus 5 over x subtract 5, 3, x plus 3, x subtract 3. That's a difference of 2 perfect squares times 6 inside of x subtract 3 over x plus 5. So let's cancel any common factors. We have x plus 3, that should be x minus 3 and x minus 3, x plus 5 and x plus 5. So what we're left with, and x, 3 and 6 can cancel, but we're left with 2. We have 2, x subtract 5, and remember we weren't supposed to cancel this one, all over x plus 3. Now your NPVs will involve anything that has been in the denominator. So we have your NPVs for this one will be x cannot equal negative 3 and x cannot equal 3. And right here we have x cannot equal negative 5. So our NPVs will be x cannot equal negative 3, 3, and negative 5. Remember, the NPVs include anything that has been in the denominator through the whole process. Let's look at another example. Once again, you may wish to pause the clip. I'm going to continue with the solution. It's going to be 2 outside of x subtract 4. And so we see we have a common factor. We have a common factor of x subtract 4, we cancel. We also have a common factor of x, leaving an x up here. We have a common factor of 2. That leaves us with 3x over 2x plus 1. So our non-permissible values will involve anything that has been in the denominator. In this case, x cannot equal -1. Here, x cannot equal 0. Right here, x cannot equal 4. And so our NPVs, x cannot equal -1, 0, and 4. So let's move now from multiplying rational expressions to dividing rational expressions. I would just like you to recall multiplying and dividing fractions. When we were in junior high, we multiplied and divided fractions, and we did 1/2 divided by 2/3 would be 1/2. We'd multiply by the reciprocal, and this would give us 3/4. We are going to do the same with dividing rational expressions. We will multiply by the reciprocal. So first, we have x subtract 2, x plus 5. We're going to factor this binomial, this perfect squares, the difference of two perfect squares, to be x plus 2 times x subtract 2. And of course, in the denominator here, there's a common factor of 2. We have x plus 5 left. We are going to now change the division to multiplication, and we're going to get the reciprocal of this rational expression. So notice now that the numerator is in the denominator, and the denominator is in the numerator. This will give us extra NPVs. Remember that the NPVs have to do with any expression in the denominator. So we have this expression is in the denominator, and this expression is in the denominator, and now we have a different expression in the denominator. All three will be included in the NPVs. So let's continue to simplify. When we simplify, we will cancel the x plus 5 and the x plus 5. We'll also cancel the x subtract 2, x subtract 2. We're left with 2 over x plus 2. But yet, the NPVs, anything that has been in the denominator. So that means x cannot equal -5. X cannot equal -5. X cannot equal -2. And x cannot equal 2. So, in all, x cannot equal -5, -2, and 2. So remember to multiply by the reciprocal when we're dividing rational expressions. Let's have a look at an example. We have 2x squared, and then we're going to factor x squared subtract 16, which is a difference of two perfect squares. We have, this will factor to be 3x inside of x subtract 1. And this one will factor, there's a common factor here of 3 inside of x subtract 4. Notice in the next step we move right from dividing into multiplying, and we have the reciprocal. This is the reciprocal. Now we can cancel the common factors. We have a common factor of x subtract 4. We have a common factor of 3. And we have a common factor of x. This will leave us with 2x over x plus 4 times x subtract 1. We have to look now for our NPVs. And our NPVs will include anything that has been in the denominator. So we have, in this case, x cannot equal -4, and x cannot equal 4. We have here x cannot equal 1, and x cannot equal 0. And right here, of course, we have x cannot equal 4. This expression was in the denominator in the first step. So we have, in total, or in all, x cannot equal -4, 0, 1, and 4. Let's have a look at another expression. As you can see, x² plus x, there's a common factor of x. We have here in the denominator a difference of two perfect squares. So we have 1 subtract x, 1 plus x. Here, in the denominator of the second polynomial, or the second rational expression, this factors to be 3x instead of x subtract 1. And in the next step, we multiply, since we're dividing, we multiply by the reciprocal. So let's cancel common factors. This factor is the same as this factor. We have a 3 and a 3. We have x², so we can cancel the x². And then, of course, we have opposite factors. So that will leave us with -1. So when we simplify this one, we have exactly -1. Now let's look for our NPVs. And in this case, x cannot equal 1. And right here, x cannot equal -1. Right here, x cannot equal 0. And of course, right here, the denominator from the first step, x cannot equal 0, and x cannot equal 1. So we have x cannot equal -1, 0, and 1. So in summary, when examining a rational expression, beware it may have non-permissible values if there is a variable in the denominator. The denominator of a rational expression cannot be 0, since that would give us an undefined expression. And any algebraic expression in the denominator of a rational expression is included in the NPVs. And we must be aware of this when we're finding the quotient of rational expressions, especially when we're dividing rational expressions. We have p of x over q of x divided by f of x over j of x. And you see that this polynomial, and this polynomial will be involved in the NPVs, since at any time during the process of simplifying, each of those will be in the denominator.